Okay, let's work this starter problem. So we've got a battery that delivers 24 volts and or has 24 volts, and it delivers 3 amps to the resistor. So here's given. So it's like we've got a here's our battery or a voltage source. It could be a DC power supply or a battery. It says a battery right here. So, and this has got an E equals 24 volts. And we've got some kind of resistance in the circuit. We'll just represent it with one resistor, R. And we know that the current flowing through, we use I for current, is equal to 3 amps. So you see how I write down what's given around a picture? I usually try to do that. And then let's write down what we're trying to find in this. A, what is the resistance? And B, what is the power delivered? And C, what is the energy? And this is why I use, by the way, a cursive E for voltage, so that I don't confuse it with E for energy. But anyway, this is the energy in 1 minute. Or I could put in T equals 1 minute. All right, so let's solve. Okay. Well, to figure out resistance, if I'm given voltage and current, I just use Ohm's law, which says the voltage is equal to the current times the resistance. And so if I solve that for R, the resistance is equal to the voltage divided by the current. This really defines Ohm's law right here anyway. So we go 24 volts divided by 3 amps. 24 divided by 3 is 8. And a volt per amp is an ohm. So that's my answer for part A. Okay, for part B, well, we use the Watt's law, or the Watt equation, the power equation for circuits. Power equals current times voltage. You close the door over there. So the power is equal to the current, which is 3 amps, times 24 volts. Well, 3 times 24 is 72, right? And then an amp is a coulomb per second, and a volt is a joule per coulomb. So they cancel, you get a joule per second, which is a watt. So that's just kind of a review of what we did last time. Now this is going back a little ways, part C. If you didn't remember it, it's all right, we're going to cover it again today. We also know that power does equal current times voltage, but power is also equal to the energy released times time. So we go energy then is equal to power times time. And notice that I'm writing down the letters E and P and T, but I'm not saying the letters. I'm not saying E equals P times T. I'm saying energy equals power times time. And if you can do that while you work problems like this, it just gets you in the mode. You learn it better. You remember what these things stand for. Well, this is power. This is 72 watts. Now, what is a watt? It's a joule per second. And you can go ahead and make that variable, that unit change if you want to. You can leave it as watts. Now time, 1 minute. Well, you could multiply by 1 minute, and you would get 72 watt minutes of energy. But let's put it in joules. And actually, if you did that on a test, I wouldn't mark it wrong even. But instead of watt minutes, let's put it in joules. 1 minute is equal to how many seconds? 60 seconds. So now the seconds will cancel. And so the amount of energy is equal to, well, I'll put a 0 on there. And 6 times 2 is 12. And 42, 43. So 4,320 joules of energy is delivered to the circuit in 1 minute. Okay? So these are the kind of electrical power problems that will come in very handy as we move on to the next stuff we're going to do, which is a little more practical.